Hello and welcome to the fourth video in this tutorial series. Today we're going to be covering for loops, functions, and a little bit of plotting. Okay, so let's create a new script, save it. Okay, let's prepare our workspace. Okay, so I first want to introduce you guys to for loops. The first example is just going to be a quick example of where we apply for loops and what exactly they do. So let's say I've got my array. Maybe I'll just introduce you to one more function. Let's say 30. So what exactly is this function doing? Well, we can consult the manual. So it tells you for different sets of inputs what exactly it does. So this is the description for this input over here. Okay, so which one of these are we using? We're using this one over here. So we've given it a maximum value. So what does it do? Well, it creates random integer values that are uniformly distributed. Okay, so between 0 and this maximum value. I've set my maximum value is 30. I'm going to be creating random integers between 0 and 30, and it's going to create a matrix of these random values, where m is 10, so we're going to have this many rows, 10 rows, and one column. So you can see n over here is 1. So we're going to create a vector where the maximum value is going to be 30 that it can create, and there's going to be 10 values, so there's going to be 10 rows. Okay, so just to show you this is what we're getting. There you go, so 30. Now a for loop follows the following, so it looks like so. So it's a for followed by an assignment. So we're going to assign values to I. We're going to assign from this list one value at a time. So we're going to sequentially go through this list and assign each of these values to I, and then we're going to perform this piece of code that number of times. Each assignment is going to mean that we do an execution that many times. So if I just want to go this I, we're going to see here we're going to have 10 I displayed 10 times. That's because there was 10 elements inside this array. Okay. Go. Well, let's say that I want to index my array and add 2 to each element. How do we do that? My array, I'm going to index the element I, and I'm going to add 2 to it. Okay, so my array, the ith element plus 2. I'm just going to suppress it for now and show you what the final result looks like. Go. So we've got my original array, and then I've added 2 to each element. Okay, and so that's just a quick simple example of how we can use for loops, but I would like to show you guys a more exciting example of how we can use for loops. So I'd like to introduce you guys to this idea of a Clifford attractor. Now, the equations that describe these Clifford attractors are just quite simply this set of equations. So it's recursive because the next point that we calculate, so each of these very, very small points, you can see these people have evaluated millions and millions of points, and we're going to quickly create a couple of our own ones. And we've got sine and cosine functions over here, and the next point depends on the previous point, but then we've got these parameters, these coefficient values a, c, b, d. Over here you can see some values for those, and they all produce different looking plots. Okay, so let's do our second example. I'll post the link to both these these pages over here. So they have got a whole bunch of different exciting looking plots. I'll put them in the description below. Okay, so let's get started. Let's first choose the number of points that we want to define, that we're going to evaluate. So let's go number of points. So this is just shorthand for 1,000. So it's going to be 1 times 10 to the power of 3. If you run this, you see 1,000. Okay, and then let's initialize our positions. So we're now going to evaluate each of these points over here, but we're going to create the variables to store those positions first. And I'll show you what this function zeros does. From the name, you might have guessed that it creates a bunch of zeros, but we just end up telling it, once again, what dimensions we want for the output. So I'm going to say that I want a vector. So each of my points, their x positions are going to be 0 to start with. Okay, so I'm going to have this many number of points, so that many number of rows, and just one column. Okay, I'm going to do the exact same thing for y. There we go, so we've initialized that position. Now let's set our parameters. Okay, so I've chosen A 1.5, B negative 1.8, C 1.6, and D 0.9. We're now going to loop over each of our points. So our index is going to be 1 through to the number of points that we've got. Remember, we want to start at the first point, end at the last point, and index every point in between as well. We're going to go to the next point. We're now just going to copy down these equations. So we're going to go the next point is equal to this equation, which depends on the previous point. Okay, so our first point is going to be 0. And then we're going to start calculating from there. So this is going to be the second point, and then we're going to loop again. We're going to do the third point all the way through until we've done all our points over here. Okay, so what have we got? We've got sine previous y value. Okay. And y looks very similar, except instead of A, it's B and D. Okay, so we've now calculated each of those points, okay, with this set of parameters. So we've calculated all our points. Let's plot them now. So let's plot these points. The plotting command, feed it the x position, the y position, and then we can set some characteristics. So I'll show you how to plot. Always consult the manual when you don't know what a function does. So it's just plotting. We feed it x and y values, but we can also add these extra characteristics. So we can set the color and the type of plot, the type of points that we want to plot. So whether they're points, circles, by default, it's just a line connecting all our points. We don't want to do that. It's just going to make things look very messy. And again, down the very bottom over here, you can find a quick example. So we're also going to make use of this over here. So you can set the marker size. We want to set the marker size to be quite small. And then that way, we don't actually ever see the points. We just more see the shape that the points all create in accumulation. So let's go black. So I'm going to choose black points. And I'm going to set the marker size to be quite small. The smallest size we can set is just 1. Okay. And I've created this function that it's just going to label my plot. Okay. I'm going to give it a title as well. It's going to be a tractor. I'm going to change the font size to be, let's say, just 12. So we run this. Let it go. We'll add one more thing. I'll show you guys that we can. What I suspect has happened is we've got all our figures open in the background. So when we prepare our workspace, it's also a good idea to just close all figures that are open. Close all open figures. Okay. So this way, whenever we plot to a new figure instead. There we go. This is interesting looking. Wonder if I made a mistake when writing my equation. Okay, so there were a couple of issues with the equations that I had written before. So we should alternate the variable that this depends on. And over here, these should be different coefficients. You can confirm over here just on the website what the correct value should look like. How the correct equation should look like. So when we plot this, we get this looking quite nice. I'm happy with this. And we can try different parameter sets. So we can see that we actually get very dynamically different looking plots by just changing the coefficients. Okay? And so I'll quickly introduce you guys to functions, and we're going to use that in order to plot all of these 4 different Clifford attractors all on the same figure. Okay? So let me introduce you to functions. Let's create a function that calculates our points. So when we create a function, the very first thing we want to do is we want to tell MATLAB we're creating a function. And we always have to create functions at the very bottom of our script. So we can't define this function further up. It always has to be at the very bottom. All the code that calls it, and all the other code, always has to be above it. Okay? So let's create this function. Show you the syntax for it. So what we do is we call it. Let's say we call it calculate Clifford. We're gonna have to pass it a couple of things. Okay, so we're gonna have to pass it the number of points to calculate, A, B, C, and D as well, and it's going to return these values so that we can plot them. Okay, so X and Y. Now we're going to calculate. So it's just complaining if you hover over each of these. It's just going to say that they're not currently being used. So don't freak out. Yellow highlights don't necessarily mean bad. It just means that there's something inefficient going on here. I'm just going to copy and paste this calculation. Okay. Now it's a good idea. So if you have a look over here, it's going to say that these X values are changing size each iteration. And it's because it's going first. I use 1. So we're going to calculate these values and okay. Now this array, it's going to be an array. It's 2. And the next it's going to be the size of 3 and then 4. Up until we get to num size. And when we do these, when we constantly have to expand an array size, it's a very inefficient process because what happens in the back end of MATLAB is MATLAB has to find a new location in memory, and then it has to map all the contents of the previous array to a new array. So it's a very inefficient process if each time it has to increase the size of the array. So we're also going to copy over the code for just initializing our arrays. Okay, so we initialize our arrays, we calculate our points, and then we return our points over here. So just to reiterate, the first thing we do, tell MATLAB it's a function. If we have some output, then we output it like so. Otherwise, if we don't need to output anything, if we just want to plot it inside here, we can. But I don't want to. I want it to return the X and Y values. We then tell MATLAB what the function's name is. Okay? And then we tell it what the arguments are, the things we have to pass to it, so the input variables. So you're going to see that, copy this, and come over here. So our third example, plot everything together. Okay, what we're going to do is we're going to calculate our values. Num points have been defined, so let's just let's comment all of this out first. Okay, so what we're going to do is we're going to calculate the Clifford attractor points for each of these set of parameters. I'm going to save them and then plot them. Okay, so over here we want to set A, B, C, and D to be these values. So 1.5 for the first one, negative 1.7, and so on for the second, and so on for these ones. Okay, great. So we've now passed each of these parameter sets to the function. So what's going to happen is it's going to calculate these points and then output them for us, given these parameter values that we've defined. Okay, and what we're going to do is we want to plot each of them on their own subplot. So I'll introduce you guys to a new function. Let's first just create a figure, and then create our subplot. So the way subplot works is, let's just create our figure. Whoa. Okay. What I did just there was I accidentally ran and we didn't suppress this output. So each time things were calculated, each time that we evaluated this function, the output was being saved to x and y. If we have a look at num points, it's a very big number, and so there's a whole bunch of points here that it's being evaluated and displaying to the command window. So that's why it's a good idea to suppress as well, because it slows down our program if it has to display to the command window. So it was just doing that constantly. So I cancelled it using Control-C. It's the same for Windows and for Macs. So you can cancel a process, click inside the command window, and then Control-C. Okay, so I'll show you again. I'll accidentally run this without suppression. It's going to be very large. Control-C stops. Okay, just finished in time. But there you go. Okay, so we've got our figure. What subplot does is it divides this figure into subregions depending on your inputs. Okay, so if we go subplot, we define regions on this figure, and then we tell it which one of those regions do we want to currently plot to. Okay, so what we do is we say how many rows and how many columns do we want to divide the figure into. Well, there's going to be 4 plots, so it'd be a good idea to divide this into 4 regions. So top left, top right, bottom left, and bottom right region. And how do we do that? Well, we say that there are going to be 2 rows and 2 columns. And then we can tell it which one of these elements do we want to plot in. Okay, so 2 rows, 2 columns. So I want to plot in the first one over here. 1. Same idea. I'll plot in the second item. And finally the 4th one. So there we go. Now we have to do the plot as well. So now let's go plot x, y. So we're overriding the values of x and y over here. You can see that they've got the same variable names as previously, but it doesn't really matter because we just want to plot. We just want to print the. We just want to plot the values of x and y. There we go. So they're quite large. So I'm just going to change the size of the figure. You can do so by coming over here. Now you can manually change it just by dragging it. But for those that might be curious, you can by default change the size of the figure as well. So equals regular. You don't have to understand this. You can just copy and paste this piece of code wherever you like. So I'll show you over here. What we're doing over here is we're choosing the pixel points to start at. So pixel 200 in the x direction, pixel 100 in the y direction, and then we're saying we want it to be 1,000 pixels wide. So it's going to start here from the bottom left, 1,000 pixels wide, and then we want it to be 850 pixels tall. So if we run this, then I get a plot that sort of looks like this, and then it plots. There you go. So now you've got your 4 different Clifford attractors plotted on their own little axis. Perfect. Thanks, guys.